This video is for section 5.2. We're working on Check Your Understanding on page 311. A standard deck of playing cards with jokers removed consists of 52 cards and 4 suits: clubs, diamonds, hearts, and spades. Each suit has 13 cards with denominations ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. The jack, queen, and king are referred to as face cards. Imagine that we shuffle the deck thoroughly and deal one card. Let's define events F, getting a face card, and H, getting a heart. In the first question, it asks us to make a two-way table that displays the sample space. So in our two-way table, we're going to make sure that we have our two variables, one in the horizontal and one in the vertical. So let's say we have heart and a non-heart. Then I would have a face card and a non-face card. Then remember we have our marginal distributions here where our totals will go. So if we would think of a deck of cards, for our hearts, we have the 3 face cards. Then everything else are our non-face cards. For the non-hearts, that would be our diamonds, our spades, and our clubs. They each would also have 3 face cards, so there's 3 of them with 3 face cards. And then same thing for the non-face cards. Total, we have 12 face cards. We have 40 non-face cards. We have a total of 13 hearts and 39 non-hearts, giving us our total of 52 cards in a deck. Then we're going to use that two-way table to help us answer number 2. It says, find P, which stands for the probability, of F and H. So the probability that a card is both a face card and a heart. So looking at our two-way table, we can see that 3 cards are both a face card and a heart. So we're going to turn that into a probability by making this 3 out of our total cards, which is 52. You can leave that simply as a fraction, 3 out of 52, or you can put that into a calculator and see that it becomes 0.058. So close to a 6% probability of getting a face card and a heart. And then going down to number 3, it says explain why the probability of a face card or a heart is not equal to the probability of a face card plus the probability of a heart. Then use a general addition rule to find what it is equal to. So that should say, and it does now say, not equal to, because this rule only works if you already have a mutually exclusive event. If the probability of a face card and the probability of heart cannot both occur at the same time, so they're mutually exclusive, then you can simply add them together. But these events are not mutually exclusive, so we can't simply add them together. So F and H are not mutually exclusive is the reason that rule does not work. So since they're not mutually exclusive, instead we're going to have to add them using the general rule, which means we're going to take the probability of F, and remember that's the probability of a face card, which is up here, 12 out of 52. Plus we're going to add to that the probability of H, which is going to be 13 out of 52. And again, remember, if I had done the probability of F plus the probability of H and stopped there, I'd be adding these together and getting 12 out of 52, plus this and getting 13 out of 52, which means I just added this number twice. So now with my general rule, I'm going to take that out, so I'm not putting it in there twice. Meaning I'm going to subtract out 3 out of 52. If you add those up and do that subtraction, you get 22 out of 52. And again, you can leave that as a fraction or you can change it to 0.423. So you've got about 42% chance of getting a card that is either a face card or it is a heart.